Saxon Algebra 1 half lesson 64. Greetings students, hello. I'm here today to talk with you about semicircles. A semicircle is half a circle. Divided right down the middle, pretend that's perfect. I often indicate a semicircle by drawing a full circle and then drawing this, and because I'm referring to just that much of it. Okay? Otherwise it looks like I'm writing in uppercase D and you don't know what I'm talking about. Okay. So, when we want to find the circumference of a semicircle, well, what we do is we take the formula for the circumference of a regular circle, which I always write as pi 2r. I'm writing it in a lowercase today. There's no rhyme or reason. The order of this may be different in the way you wrote it down. That's okay. But it's important that we have the radius version because we're going to divide it by 2, right? Because we only want half the circle, so we take half of it. Now, what's cool is those 2's will cancel. So the formula for the circumference of a half circle can be simplified. It's just pi times the radius. Oh my gosh, that is so easy and cute because of the way those 2's cancel, right? Now, if we want the area of a half circle, we take the area of a full circle, just like we did there, pi r squared, and we divide it by 2, but it doesn't cancel like this. Oh, we can't cancel those. That doesn't work. So when we're doing the area of a semicircle, we just have to do the regular calculation and then take half of it. All right? But the circumference makes this nifty, cute little new one. So I'm going to show you how we can use this new information in exciting ways. Oh, I wrote 64, but I was writing 46. All right, I saved the day. All right, so what we're supposed to do is take this figure. Now, our figures are getting more and more complicated. Have you noticed? Okay, I'm drawing everything that John drew, and you're drawing everything that I'm drawing. We're having fun, aren't we? Okay, this is our figure. Dimensions are in meters, so I'm going to put an M here. I don't need to know that until the very end of my problem, and then I just put that label on my answer so that my answer has a label, right? We just put it on at the end. It's not part of the calculation. All right, the first thing we want to do for part A is find the perimeter. Perimeter is going around the edge. Now, the semicircle is the hardest part of this because we have to switch over and use a different formula. So I'm going to start going around right here, and then I'm going to go around this way and add everything up. So for the perimeter, I'm going to need to add 15 plus 11.18 plus 10, and then the last bit will be the semicircle, right? So then I'm going to use my circumference of a half circle equals pi times the radius. I will look at this and go, oh, look, my radius is 5. That's what this is showing me. There's the center. There's the radius going out. So all I have to do is multiply 3.14 times 5. I don't know why I put parentheses around it. Ignore that. Let's multiply. I get 15.7. Right? So I add that to my list here. And now I'm ready to add it all up. And I get 51.88 meters. That's correct. I box it. I just added the meter unit to it. I'm happy. All right, so that's how we can use the circumference for a half circle formula. It just makes a quick, simple calculation we don't have to use the original formula and divide by 2. We can use the, I was going to say cheaters, but it's not cheating. It's the efficient form for the half circle. All right. Oh, sorry, I'm yawning. I'm yawning so much. Okay, now let's do the area. What I'm going to do is I'm going to switch colors, and I'm going to do the area in green because we have to mark things a little bit differently. This is B, and we're doing the area. Okay, so for that, we're going to divide this into 1, 2, 3 shapes, right? So first, let's do the triangle. The formula for the area of a triangle is base times height divided by 2. The base, we don't know the base, but we can figure it out because it's 10 taken away from 15, so the base is 5. The height, now this is tricky, and I don't know if we've talked about that. We need the height of this. That's going to be the same as this. Keep in mind that the radius is the measure from the center of the circle to the edge of the circle, anywhere you care to find it. So these two segments are also radii, so they're each 5, just like that radius, and that means we know that the height of this is 10. Oh, sweet, right? So we always use that trick of finding the radius and then doubling it to get this dimension, the diameter of the circle. All right, so it's 5 base times the height is 10 divided by 2. That cancels. The area of our triangle is 25. We're going to add the 3 pieces together, right? Right, teacher. Okay, thanks. All right, now let's do the rectangle, or in this case, it does happen to be a perfect square, right? But we do length times width. And I want you to set these up just like me. The perimeter calculation should look just like that. The area calculation should look just like I'm doing here. The way you arrange these chunks on your paper is up to you, but I want your perimeter calculation to look just like that. Okay, length times width. Don't get tricked by this 15. Remember, that includes 5 for over there. So it's 10 times 10. That's 100 for the area of our square. You can say rectangle, though, because squares are part of rectangles. Okay, now for the semicircle. And notice how, to indicate my semicircle, I do this same lovely piece of artwork. It's my modern abstraction. And what are we doing? Oh, we're finding the area. So we have to do pi r squared divided by 2. Oh, it's so sad. And that would be 3.14 times, what's our radius squared? Our radius is 5, so that's 25, and it's divided by 2. All right? You run through the multiplication on all that, and you will get 39.25. Right? I'm going to trust that you know how to do that. And now we add. $164.25 meters squared. Area is always a square. That's the way John is going to do a bazillion homework problems in your future, where he's going to give you the picture and ask you to do both the perimeter and the area. It's so much work. It's so much work, you guys. When you finish one of those, I mean, if you don't do a touchdown dance, at least push your chair back or roll over on your bed for a minute and go, oh my gosh, I survived. It was deathly, but I did it. All right? Make sure you have these written in your book. I'm going to flip my page and I'm going to write them again at the top. I'll meet you over there. Go ahead and write in your book. Okay. Remember that you should have whatever formulas you need written at the top of the page in your homework. You don't have to write it for every single problem on that page, but you need to be able to see this when you're doing a problem that includes it. Okay, let's do 64.2 And that is the last problem in this lesson. It is another two-parter, so let's draw the picture. It goes like this. Drawing the picture, you guys, I highly recommend that you draw the picture because it helps you understand the problem so much better. And I will say I've run into parents that don't understand that. They think it's a waste of time to draw these pictures. And I have explained to them, no, it's not. It's actually very useful time spent by the students wrapping their head around what exactly is going on in this problem. So please take the time to draw the diagrams, and if your parents are telling you that's ridiculous, send them to me. Okay? All right. Now, I draw my diagrams as carefully as I can, but the scale isn't always perfect. Like this 4 and this 6 and this 5, they don't necessarily look like they're proportional. That's okay. As long as we just have something that we can mark up and write on, we're fine. All right. This one's going to make us think, isn't it? So let's start with the perimeter. That's part A. I always start here and go around and do, well, this one's got 2 semicircles, but I always do the semicircles last if I can help it. Let's start measuring. Okay, how long is this side? Well, I don't even know. Oh my gosh. But here we have to do our radius trick, right? If that's 4, then this is 4, and this is also 4. And then I add 4 and 4 and 6. This must be 14. Get it? Tricky, right? And then over here, this is 5 and this is 5, so this must be 10. All right, so when I start to add my perimeters, I'm going to go 14 plus 10 plus this one, which is pi times the radius, which is 4. We'll finish, and we'll do that calculation and put that number in right there in just a second. But I want to get this 6, and then I want to get this one, and then we'll have gone all the way around. This will be pi times 5. I'll put parentheses around that so it looks a little more like we're multiplying. Okay, so now I've gotten this side, boop, that 6, boop. Okay, we'll be good. So let's just multiply 3.14 times 4, 12.56, and then we can just add 3.14 to that to get 5 times, right? 15.7. Okay, and that goes right there. All right, so there's our calculations for how we got those 2 numbers. Multiplying by pi is never easy. It always feels like sort of like a ball and chain. It's just dragging down our calculation, right? Just be thankful you only have to multiply by 2 decimal places. All right, let's add 6, 5, 6, 7, 13, 18. Our unit is centimeters. I'll give you a second to catch up. All right, so the perimeter calculation for the first one tells us that it's 58.26 centimeters around the edge. That's a measurement of length, so it's not squared or cubed, right? It's just length, a piece of string going around. All right, let's do our area calculation. I'll just stay in this color. We have 3 shapes, don't we? We have the main rectangle, and then we have 1 semicircle, and then we have another semicircle. All right, let's do the rectangle first. That's length times width. That is 14 times 10. And that, my friends, is 140. I'm here to help you with the hard parts, right? All right, and then Our formula for both of these is going to be pi r squared divided by 2, right? So that will be, for this first one, it'll be 3.14 times, this will be times 16, right? Because the radius is 4. So we squared that and then divided by 2. Now, I like to write it out like this first because, I can do 3.14. Oh, look, I can do 3.14 times 8. I've already figured out 3.14 times 4. Let me show you how I'm thinking. 3.14 times 4 equals 12.56. So if I add that with itself, then I'm getting 3.14 times 8 the easy way. Does that make sense? Or at least it feels kind of easy to me. So this is 3.14 times 8, 25.12. Here's what I'm going to do. I'm going to draw a little box around this because this is my workplace. 25.12. That's for the first one. They're both using that formula, but they're different. Now I have to do 3.14 times r squared when r is 5. Oh, that's 25. And then I have to divide it by 2. 25 is not an even number, so that's not going to work very well. But what I could do is create a decimal number there. I don't want to do it in 2 steps, is what I'm getting at, you guys. I want to cancel this so that I don't have to do multiplying and then dividing. So I'm going to do that. I'm going to divide 25 by 2. That's 12.5. Then I'll just multiply 3.14 times 12.5. The decimals I'll sort out in the end. These are all simple numbers, so I'm okay with that. 5 times 4 is 20. Put in a 0, do the next row. Put in 2 zeros, and then get the third row. Does that make sense? What I like about this multiplication too is these are all pretty easy things to multiply by. I like to keep the numbers simple. You know how that is. Now we will add. And that's a 5. Let's count our decimal places. 1, 2, 3. 1, 2, 3. So that means the area of this semicircle goes there. And now we've got the areas of our 3 components. And we add them together. Put a unit on it. We're working on area, so it's always squared. And we get 204.37 centimeters squared. That's the correct answer. This is all our work area. Right? If you're the kind of person that really likes your homework to be beautiful, A, I'm with you, but B, all these hand calculations are a part of the problem. Don't you dare do them on a separate piece of paper and throw them out. They are a very important part of the homework, but this isn't the most beautiful. But find ways to box them off or do them to the side or do them at the bottom of the problem. Find a way to do it so that you can live with it. But this is important. Don't you dare throw this away or do this on scrap paper. This needs to stay with your answer so that anyone can see your whole thought process at once as they do it. Okay? Some students get really hung up on that, and without being genderist or offensive in any way, it's usually girls who like their paper to look really, really neat and clean. And I'm with you, sisters, but we have to keep our math on the page. We can't just throw out what's not cute. So find a way to make that work. I like to box it off like this, and it always looks a little scrappy, but that's okay. That scrappiness is part of math, and we love it. All right, 64 is done. Another week in the can. People used to say that when they made movies, because after you made the film, then you put it in a big metal can. So when something was done, you'd say, that's in the can. I am just filled with throwbacks tonight, aren't I? All right, that's lesson 64. That's the end of your homework for the week. I will see you on the video chats. Looking forward to it. We'll catch up. Mr. Joel, you missed last week's check-in, so you will owe me 2 review problems this week, not just 1. We'll catch up on those. All right? Okay, look forward to it, sir. And ladies, you just have 1 each. Okay, goodbye.